Welcome back to the online classes. This is Zafarullah Mangi from the Department of Mathematics. As you know that students, we have discussed about the properties of sets, algebraic sets, in which we have already done commutative law, associative law, and so on. Now we are going to start the topic relation and their properties. So in this lecture, first of all, we are describing the previous topic which is included our syllabus. So therefore, first we review of that topic, which is Cartesian product. As you know that students, the definition of Cartesian product we have already done this topic, but now we are repeat again in this lecture because the relation topic is our main topic and basic topic. That's why we are a review to this topic. So the definition of Cartesian product is that an ordered n-tuple, this n-tuple must represent that in this bracket there is different, means many number systems. If there is any number, n represent any number. If this order shows that there is 3 tuple, it must be a1, a2 and a3. Only 3 numbers are included. But if he says that n ordered 4 tuples, it must be there is only 4 digits in this bracket. So here n ordered n tuple, it must be the numbers are 1 from n. This is 1 a1, means this is any digit a1, a2 up to so on, and end with the number an. So here it is represent. So an ordered n tuples from a1 to an is the ordered collection that has a1 as its first element. So we are seeing here that a1 is our first element and a2 is our second element and so on, and this is our last an as its nth element, or you can say that an is our last element. So if we say that there is 2 tuple, there is, when this definition, this ordered pair says that there is 2 tuples are called ordered pair because there is only 2 digits. So that's why we can say that this is only ordered pair, because order shows that the number in between this bracket, how many numbers in between, in this bracket, in between this bracket. So the order must be represented in this bracket, how many digits are covered. So if we say that ordered pair must be represent only 2 digits. So that's why we say that 2 tuples are called ordered pair. So let's see here, a comma b is equals to c comma d. This ordered pair is equals to this ordered pair when if a and c are equal and b and d are equal. If and only if a is equals to c, because there is equal system. In equal system, there must be both sides are equal. So that's why we can say that this ordered pair equal to this ordered pair. So let's suppose example 1, 2, 1, 2. Let's suppose is equals to 1, 2. So this one is equals to this one, and this 2 is equals to this 2. So here this is represent 2. Okay, this is 2. So when first element is equals to first element and second element is equals to second elements, that's why we can say that this ordered pair is must be equal. Now same here, this conditions represent that A equals to C and B equals to D. It must be says that A equal hoga C के and B is equals to D. So that's why we can say that this ordered pair is equal to that ordered pair. Now again see here, second example, A comma B is does not equals to B comma A, because we see here A is equals to C and B is equals to D. So that's why we can't say that A doesn't equals to B, A does not equals to B, and B doesn't equals to A. So this is our main. Now see here, so that's why we can say that these two ordered pair are not equals to each other. Now the second main definition of the Cartesian product is that the Cartesian product of the sets A1, A2 up to AN denoted by A1 cross product A2 cross product, so on, and it must start from A1 to the AN. A capital represent any set. Okay, so A1 must be represent set 1, A2 must be represent A2 up to AN, means it all represent sets. So the Cartesian product of the sets A1, A2 up to AN denoted by A1 cross product A2 cross product AN up to is the set of ordered n tuple, because there is many sets from A1 to AN. So that's why this ordered pair represent n tuples from 1 to the n, where AI represent one element to the n element, because 1, 2, 3, you can say that this I represent n, this I represent n numbers from 1 to the n numbers. Now see here, we are written the Cartesian product in this form, A1 cross product A2 up to AN, and this ordered pair represent this form. So all the A1 belongs to AI, because this 1, 2, 3 up to represent 1, 2, 3. So I must be represent the sets of the elements. How many sets and how many elements in between these sets. Now let's go to the main definition, which is binary relations. So the definition of the binary relation is that let A and B be two sets. A and B are two any sets. A binary relation means bi means two and nari means numbers. Bi means beta two and nari means numbers. It must be the relation in between two numbers. Which numbers? A and B. This R represent relation from A to the B is a subset of the Cartesian product A cross B. Actually, this binary relations always done in Cartesian products, so that's why we are writing this binary relation into the Cartesian product. So notation: X relation with Y means X is our input and Y our output. These both belongs to the relation, and X is said to be related to Y under R, under relation. X does not, this line represent does not relation with Y, so that's why it denotes X comma Y does not belongs to R. If this relation is not in between both sides, so that's these two numbers are not included in this relation. Now let's see here an example. Let A be the set of all cities. Let any country contains all cities. Just as Pakistan, there is many cities. Number one is Karachi, Hyderabad. You can say that Sakkar, Larkana, Lahore, Islamabad. Many cities are included in one country. So A represent any country, B the set of all cities, and let set B is the set of all states in the US. So there is represent US. Define the relation R from A to the set B. By A comma B belongs to R if city A is in state B. If city A in state B, some ordered pair belongs to relation R. Let's suppose this relation East Lansing, Michigan. This East Lansing is a city and this is a state. Boulder, this is city and this one is a state. So here if city A must be represent city and B must be represent an state. So this city in the state of this area. Now Chicago, this is represent the city and this city in the state of this one. Columbus, this is a city and this is included in this state. So there is many relations in between them. So this A relation, because city represent A and state represent B, so this East Lansing relation between Michigan. So Boulder related relations Colorado. So these are the main relations in between that. Let's suppose another example. Let our province Sindh is a state and there is big cities. Big city is Karachi. Let's suppose there is a city and the state is Sindh. City Karachi is relation in between Sindh. Okay, because the relation of Karachi through the Sindh. So there's a relation in between city and state or city in province. So now another example. Let A contains 4 elements A, B, C, D and B contains 3 elements. Then relation A directly relation to 2 because A only relation with 2 and here B relation with 1, B relation with 2, C relation with 3, D relation with 2. So let's see here in this example, A relation with which number? 2. So A is direct relation with 2 and B relation with 1. So B relation with 1. B also relation with 2. So there is an other relation. B is relation with 2. Now C relation with 3. C relation with this 3 and D relation with 2. So this is our main relation in the form of ordered pair. This is ordered pair because there is 2 only numbers, A and 2, B and 1. So that's a relation. Now see here in this example, is this relation a function or not? So there is a big difference in between relation and function. Relation must be first element of the ordered pair have different elements. Let's see here, B relation 1, B also relation with 2. There is one digit relation with different numbers because B is same, but this number and this number is different. This one digit, this B only relation with 2 numbers. So that's why this form of relation we can say that this is only relation, but not see this is function. Not say that this is not a function, because function always be only takes one element to the domain. So see here, A relation with B, so that's why this is X. Same here. B relation 1, so that's why B relation 1, so this is in front of this relation to this relation. This is triangle form. B relation with 2, same also B relation with 2. C relation with 3, C direct relation with 3. D relation 2, D relation 2. Same here. Because A not relation with 1, so that's no any number. A does not belongs to 3, so there is no any number. B does not any 3, so there is no any number. So this is form of relation. Function is relation. Now see here, the main topic function as relations. Recall that let function A belongs to A mapping B be a function. The graph of function is the set of ordered pair. Set of ordered pair. But there is big difference in between both ordered pair. Now see here, the graph of function from A to B is a relation from A to B. Yeah, there is a point which is very important, and that point is every function is a relation. Every function is a relation, but not every relation is not a function. Sometimes a relation is a function, but we cannot say that every relation is not a function. Okay, beta? Now see here, conversely, if R is a relation from A to B such that every element in A is the first element of exactly one ordered pair of R, then a function can be defined with R as its graph. Now same here, we can say that in function every input, or you can say that for example we are using our mobile phone. If we are going to gallery and we search any video, so we are not going to the text message box, because our need is only to see the video, but we are not going to the text message, because there is no any video form, no any gallery. So that's why we are going to only gallery. So which we are give the input, that type of output is coming. So here the function of the definition is that every input contains a unique output. In simple, you can say that every number gives us a different element, one different element, or one element. This situation in this form, we can say that this is a function, because we give the one input and the outcome is also one. But in the sense of relation, if we give one input and it takes more than one outputs, so that type of relation represent only the relation, not function. Now see here,